Hello, the Darkness344 here. Today I'm going to be showing you this simple text display that I made, and in the future I may make a tutorial on it. It's pretty simple the way that it works, and yes, rendering. And yeah, I wouldn't call it small, but it's not exactly large. It's more just simple, to be honest. And it works quite nice. I'll probably, if I can remember, leave a world download in the description. And this basically has 32 different characters that you can put in. Well, I mean 32 places. So 16 on the top, 16 on the bottom. And you can put the letters A to Z in, or Z, as some people say, into the thingy, and it probably is kind of laggy, but that's because I've used pistons where I probably could have done something else with torch towers, but it works fine. So just a a lot laggy. And I've also started to try, I've been recording with my GPU software instead of Streamlabs. I can't remember what I used to use before. OBS Studio, but because I think this it was lagging for some reason. I don't know why. I had to turn down the quality. So hopefully recording with the GPU software should just work a slight bit better, and hopefully quality should be a bit nicer. So let's actually show off the different components to this. So first of all, over here we have a very simple QWERTY keyboard. So yeah, that's pretty simple, but you only have a space button on it, as you don't have any like backspace or any of the like symbols or stuff. I could have done symbols, but it'd have just made this display a bit larger, and that would have just been a bit annoying. So this has all 26 letters, sadly no numbers, because that would have been larger, as I said, and with this many pistons, I should really not have used pistons. It would have been kind of a bit too laggy. That's what I was saying in my last video about different types of storage, which is over here. As you can see, they all render in because they're not proper blocks, they're block entities. As I was saying about this video, using all these barrels and all these pistons would make it quite laggy, and as you can see, it does make it kind of laggy. I'm not sure. I have medium kind of specs, so RX 580 and a decent CPU, so it shouldn't be super laggy. It just doesn't really like it too much. So over here we have a single segment or cell, and as you can see, it has all the letters, and these letters are basically just torches like this, and when they turn on, it lights up the according segments, so you can tell which letter to light up with it has a binary decoder over here, so you can put in a binary value into it, and it will decode what value you put in, and it will choose the according letter. So say the letter A would be the number, I think it's 01000, or I read that the wrong way around. It's the number 2 basically, and then it would turn these torches on, which would then light up the correct segments over here. So that's very simple, and it's pretty simple to do. You have your decoder on the top, and you have just all of this, which controls the individual pixels. So when it came to pixel choice, like how to display the letters, I choose a simple grid like this, and that is mainly because I wanted to be as small as possible, and if I wanted to have diagonals in the middle, because normally you'd have your display 3 blocks along like that, 4 blocks like that, and another 3 blocks, and then you'd have a diagonal like this, and then you'd do that on all sides, so you'd have another 4 like this, and I've done that incorrect. You'd have it like this, I think. Yeah, and then you'd have a diagonal going in like this, and then you'd have 2 more over there, and that would be able to display all letters, capital and non-capital, very easily, and I'm pretty sure you'd be able to display numbers too. However, I chose this design because there's less bits, segments to light up. As you can see, you only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 segments to light up, where on this one you'd have an extra 1, 2, 3, 4. And that would be kind of inconveniencing, as a lot of the space over here is been used up already. So now to the actual function. So this is a basic 5-bit binary input for the letters and another 5-bit input for the address. So this would be 0, that would be 1, that would be 2, that would be 3. So you put in the address of which segment you want to light up, and you also put in the letter. So if I wanted to light up the 3rd segment, which would be this one, then I'd put in the address 2, because 0, 1, 2, and I'd also put in the letter address which I'd want. So for A, I'd also put in 2 or whatever it is in binary. So over here we have the keyboard again, and it basically, you click a button and it turns the corresponding torches on, as well as sending a pulse to the serial device over here, which basically turns the binary which you get output from these registers, just save it, so you have like a little cache kind of thing, and it turns whatever's in these registers into serial, which is basically a bunch of different pulses, because it means you only need 1 wire instead of 5 wires. I mean, well, actually, I have a bunch more wires over here, which I'll go to explain in a bit. But as you can see, it just travels down this line all the way up here. Oh yes, glass is the best. Haha, imagine Java edition. You can't do, well, I'm not going to do it actually, it's going to break. Java edition, you can't do this. Oh yeah, it can actually go down glass. Imagine all the cool possibilities. Though Java edition has a lot more better redstone features. Enough of that. So over here we have the actual decoder for the serial device. So the serial data comes in, gets decoded. This is of course the same decoder that Mizuma Games made, which is a very epically small and compact serial decoder that is 1 tick per bit, which is the fastest you can get with using repeaters, I'm pretty sure, which is very cool. And as you can see, it just comes in, gets decoded, and then a bunch of different logic dictates wherever it goes to which different bit, which I'll come on to. So the serial protocol that I'm using is just my standard SDB 2.1, I think I'm on, and that basically means the first 4 bits are the address of what device you're going to be sending to. The next 4 bits are the command for that address, so say to like read data, write data, or do this or that, and then the next 8 bits are the actual data. As you can see, we only have 5 bits here, but you'd have 6, 7, and 8, though I just don't put them in because we don't use them. And that is how it's a very simple protocol, and I probably could have just combined the address and the command in one. But the way the address system works is, if the address you're sending is the exact same as the address of the device, so the address of this device would be 1, then it will actually use the data and do whatever it says with the data. But of course you can easily change the address just like that. Very simple. Yes, it is kind of lagging because of all the pistons. So I have 3 different commands for this. Display, you have 1000, which is type letter, so that just type a letter. And each time you type a letter, it gets shifted across one. So the next letter you would type would be over here, next letter would be over here, 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 and so on. This does backspace, which means it shifts it back one. It doesn't delete the letter, so you don't know that it has gone backspace, but it basically means instead of, so say there was a letter here, right, and then I went forward one, so I typed a letter in here, then I typed a letter in here, but then I put the wrong letter in here by accident, So I would like to replace that letter, but it's already gone onto here, hasn't it? So you have to click backspace, which would shift the counter back to here, and it would replace that letter with the new letter you put in. So that's what that does, kind of. Then you have this, which just clears everything, clears the counter and resets it all, which is what I'm going to do right now. So we just put in the command, and then we also address the cell, and then we can just click send like that, and it should do it automatically. Also on this keyboard you may have seen this, which is basically a binary interface, so you can put the letter in binary and then just send it, which means it's just kind of useful instead of just clicking a random button. If you know the binary code, you can put it in. Well, it's not really that useful, but I mean, say there were like some characters that weren't on the keyboard that were programmed into the display, you could like address the binary value of that character and just send it. And there is one character that is not on this keyboard, which is an underscore, because I was going to use that for something else, but I just never did. So you can address the underscore by sending that. There are a few other bits which I'm going to explain in a minute, but let's actually try this out because it's been kind of too long. So we're still on this address, which I'm pretty sure is the right one. So if we look at this, yes, we've got the address correct of the actual device, and now we're going to send the command. That's going to be our command, because a 1 is just type a letter, and let's just type the letter E, and that should just send it down the keyboard, and eventually it will display. It'll probably take a long time because it's slow display. There we go, the letter E, and it doesn't look that good, but oh well, I'm not that good at making letters. Now we're going to type the letter A, because sure, and then it should eventually shift over and write the letter A over here, as you can see. And then you can just there is a space button, so you can put a space in, which will not display, but it will do a space, and then we will type an S. I don't know where this is going. But yeah, it works fairly well. It's, as you can see, there are some lag, spikes and stuttering. Yes, S. But it works pretty well, and I'll just demonstrate the backspace feature right now. So we're going to go around here. I should have made an actual backspace key, but oh well. Too late now. We're going to do the backspace feature, and we're going to replace that with the letter U, sure. It was just there, so I chose it. So eventually that should be removed and be replaced with the letter U. And if it doesn't get replaced with the letter U, it just means you have to enter the letter U again or something like that. I can't remember how I did it. Yeah, it's not really doing anything, is it? So I think you have to click the letter U again, but actually send it as a proper input. So if I go like this, I'll just click the letter U again, and it should be replaced with the letter U. And of course, once you've got to the end of this line, it will automatically carry on from down there. Also, you might have to, like, if it's not appearing at the end of the line, you might have to like fly over here, because I'm pretty sure it might be a bit more than 12 chunks, which would be a bit annoying. Oh look, there we go. As you can see, it has been replaced with the letter U. Pretty cool. On to some other logic. As you can see, there is a lot of rubbish going on. It kind of looks like just a mess. So over here, I'll try and explain it nicely though. Over here you have your serial decoder, which turns the pulses of the serial line from the keyboard into actual stuff that makes sense for this. And so you have your letter input over here, which was the number it gives. You have your address over here, which is the address of the device. If this address is not the same as that, then it will not go into this device, basically. So it has to be the same, or this will not accept it. Then over here, you have the command input, where you have a little decoder over here, which decodes the numbers you have. So you have the, I think I put the commands on these signs. You have the add letter command, you have the backspace command, and you also have the clear all command, which is clears the counter, which I'll show in a minute, as well as all the display, which is quite simple. I just have a line over here that clears the bits of the display. So, oh yeah, the one last thing of this display segment that I didn't talk about was over here you have a little set of registers which basically saves the input, and you can clear it or put a new one into it. So that's what that does, and I'll explain some of the little decoding bits in a minute. So over here we have a big mess of wiring. So this basically is a program counter, so you can increment it or you can decrement it, which means add 1 or minus 1 basically. Well, you can increment it by 1 or decrement it by 1, that makes more sense. It's a very bad design, partially by me and by someone else. Someone else made the good part of it, I made the bad part of it. If that makes sense. I can't remember their name, but I'll try and include them in the description if I can remember. But over here we have their design, which is it is a Java edition thing, but it does also work in Bedrock, luckily, because it was made like 8 years ago, so it still works. So you can put in a pulse, and as you can see, it starts counting in binary. So it's basically a binary counter. So 1, 2, 3, 4, 5, etc. And over here, this line basically either resets the counter like this, so you can reset the counter, or if you actually put data into this, like this, so we're going to put the number 5 into it, when you go like this, it puts the number 5 into the counter. Very, very useful. So this is a very simple algorithm. I couldn't be bothered to understand how it works, even though it is extremely simple. It basically flips certain bits and just does certain things, because this is just adding 1. I wanted to take away 1 as well for the backspace feature, and I couldn't be bothered to work out this, so I just added a very small, kind of small subtraction module onto the bottom over here, which uses 2's complement to just subtract 1 away. So as you can see, you have the number 1 in it, and it just subtracts that away from the number that comes out. So if you want it to, let's just I can't reset it. So we have this number at the moment. So which way do I read it from? So 11001, but say we wanted to minus 1 away. So over here I can just minus 1, and as you can see, we have just minused 1. Say I want to minus 1 again. As you can see, it just minuses 1 each time. Pretty simple. All it is just a subtractor, and this subtractor design is by Nubosaurus, which is a very cool, nice, compact ripple carry design. I should really design one of my own one day. It's been too long. Then we also have, I hope that notification didn't sound. I basically added the subtractor on and then flipped it round this way. So you have it, I used the structure block to rotate it around this way because I built it around the wrong way. And then I just pasted this with the structure block. Yes, unfortunately, this axe in my inventory is not a world edit axe. It is just, let's actually show you. This axe is for getting around this world. Sounds stupid, but I have a lot of stuff in this world. There is no proper world edit in Bedrock Edition, sadly, so you have to use structure blocks, which are alright. They're just a bit annoying because you have to, let's actually show them. You have to place them down and then just configure stuff like that, and it's just kind of a bit annoying when world edit would be a lot more useful. So I just placed this in over here. You do have amulet, but that's not an in-game world edit. So I pasted it down here, and it basically just feeds into the input over here, and not the letter input, but the actual address of the cell input. And it's very simple. Well, I kind of overcomplicated it. I have a decoder over here, so this line from the counter is fed into the decoder, which is fed into these pistons as well as this piston over here. I did not need these pistons. These are kind of useless. They don't do anything. However, I mean, it still works with them or without them. This piston, however, basically allows you to either write to the cell or not. So if this piston is up, it means you cannot write to this cell, and if this piston is down, it means you can write to this cell. So if I entered the address for this cell over here, basically this piston would go down, and when you send the right pulse, which is just over here, it sends a pulse down through all the cells, and if this if their piston is down, it will just what's the term? It'll basically save whatever is coming in from the letter address to the cell. Pretty simple. So yeah, I might do a tutorial on this. The only problem I had with this is, well, one, the lag because of the stupid design I made with pistons, and two, the stupidly complex timing circuits which I added in, which was very stupid of me to do all these random timings, but it works. What does this mean? Ah yes, that was, I guess, when I was making this, I needed to break the pulse to do certain things. But yeah, I'll probably, hopefully, leave a world up for download. So, I guess, yeah, have fun playing around with this. See if you can create your own, if like maybe a better version, more compact version, less laggy version. Totally not looking at the pistons right now. And yeah, I guess please like and subscribe. And special coming up with this computer soon. But yeah, please like and subscribe, and I am out. Thanks for watching. See you later.